What about if I did 4 coins? Now I'm going to have 16 possible outcomes. If I roll a die, we know from yesterday there will be 6 possible outcomes. If I roll 2 die, we know that there will be 36 outcomes. But what if I roll 3 die? 216 outcomes. So the number of outcomes raised to the number of events is going to give you how many outcomes you have. Again, we can see here if I have 2 dice, I have a possibility of 1 through 6 on the first one, and then the second one each time I have 1 through 6, so a total of 36. Let's take a look at another example. A marble bag contains red, white, and green marbles. If I'm going to choose 2 marbles from the bag, how many possible outcomes are there? Well, I have 3 things, red, white, and green, and I'm going to choose 2. So I'm going to take 3 and square it, or take 3 times 3, because I'm going to do it once I have 3 chances, a second time I'm going to have 3 chances. What are the possible outcomes? Well, you could kind of do a tree diagram and write that down. And are they equally likely? Well, as long as it's a fair game, then yes, they would be equally likely. So you can see here, just by doing a tree diagram, you can see that you do have 9 possible outcomes. Lunchtime. So let's take an example where you can choose either soda or juice. You can choose a bagel, rye bread, or white bread, cheese, pastrami, roast beef, or turkey. And you have to choose one from each category in order to make up a lunch menu. How many different possible lunches are there? Well, I have 2 choices for my beverage. I have 3 choices for my bread. And I have 4 choices for my meat, protein, if you will. So 2 times 3 times 4 is 24 different lunches that are possible. If you take a look at a tree diagram, this is what it would look like. And if you count all of these lunches up, you will see that, in fact, it does equal 24. So the fundamental counting rule says if one event can occur m different ways, and the second event can occur n ways, the number of ways that both events occur is just multiplying them together. The rule can be extended to any number of events. So at a restaurant, you have a choice of 8 different entrees, 2 different salads, 12 different drinks, and 6 different desserts. If you are to choose one from each category, how many different dinners are possible? 1,152. You have 8 different entrees, times 2 different salads, times 12 different drinks, times 6 different desserts. How many different 7-digit phone numbers are possible if the first digit cannot be 0 or 1? So you have to think about this. How many possibilities are there for the first digit? Well, if you're talking about 0 to 9, you've got 10 different possibilities. But if the first one can't be 0 or 1, for the first digit, you only have 8 possibilities. The second digit, you would have 10. The third digit, you would have 10, and so forth. So repetition is allowed. So I would have 8, 10, 10, 10, 10, 10, 10. Multiply those together, and you get 8 million different possibilities. But what about if we looked at this same example and we said, well, repetition is not allowed. If I used the number 5 in the first slot, I can't use it again. So again, my first possibility for my first number cannot be a 0, 1, so I have 8 different possibilities. The next one, I have 10 different possibilities, but on the second one, I still can't use whatever I had for the first one. So if this one was a 5, the second one cannot be a 5, so I only have 9 numbers to choose from. For the third number, if this was a 5 and this was a 3, then this can't be a 5 or a 3, so now I only have 8 numbers to choose from, and so on and so forth. Multiply those together, I have 483,840 different possibilities. How many different arrangements of 8 people in a line are possible? Well, if I take 8 people in the room and I say go line up, how many possible people could be first in line? Well, 8 people could be first in line. But now that one person is already first in line, how many people could be second in line? Well, now only 7 people could be second in line because someone has already taken the first slot, and so on and so forth. So 8, 7, 6, 5, 4, 3, 2, 1. Multiply those together, and you get 40,320 different possible arrangements of 8 people. This can also be written as 8 factorial. That little exclamation mark means factorial. So that means take 8 minus 1 times 7 minus 1 times 6 and so forth. So 5 factorial would be 5 times 4 times 3 times 2 times 1. Or 100 factorial would be 100 times 99 times 98 times 97 and so on and so forth all the way down to 1. In your calculator, if you want to do 8 factorial, you're going to hit your math. Well, you're going to hit 8 and then math, probability, and then 4. And it will give you this 8 factorial. If you have any questions,